Okay, so 2016, section B, question 2. Figure shows the design for a child's piggy bank. The curve ABC is an ellipse, and point B is on the curve. Determine the length of the major axis and draw the ellipse. The curve KM is a parabola with vertex M. They're the first things I'm going to do. Straight away, I note that we're given the radius of the minor circle. Okay, we have no focal points. B is a point on the curve, and we have no major axis. So we're going to work backwards with the concentric circles method. So you should pause the video, have a quick think, sketch it out how you might do it to help your problem solving skills. Okay, so I'll pick my center point here. I'll move the visualizer down here for you. Right, the radius of the minor circle is 55. So I'm going to set my compass to radius 55. And I'm going to draw in the minor circle. Right, now there's the minor circle. Check where point B is. It says point B is on the ellipse. So locate point B for me. Have a look and think about where it is. It's up 40 and across 60 from the minor axis. So there's point B. B is on the ellipse. Now, when you're given the point B on the curve and the minor axis and no focal points, go parallel to the major axis towards the minor axis until it hits the circle. From there, draw a line from the center through here, as you see me done. Right, now, from B, go parallel to the minor axis away from the middle. And that's the point on the minor circle. It's working backwards from the normal concentric circles method. Compass here. Alright, nib out to the point there. Draw in your major circle. Okay, divide up your circle into your segments 60-30. I'll do one at the bottom. And then I'll draw in the rest of them. So where the division line hits the major circle, go parallel to the minor axis towards the middle. Where the division line hits the minor circle, aka the small circle, go parallel to the major axis away from the minor axis. And that's a point on the ellipse. Now I'm going to repeat that concept all the way around. So I'll pause the video and do that. So I've got the ellipse drawn in. Now we're going to target the parabola. So point E here. What does it say the distance between E and M is? Check your question sheet. Okay, learn to get into the habit of using that. It's 22. And the distance down from E to line KN is 20. So that's where, the feet will be resting. Now, the KMN is a parabola, alright? And it says that the bottom of the parabola is a distance of 54. So I'm going to mark 27 to the left and 27 to the right. Okay, and we're going to draw in a rectangle that fits at size. Okay, so line across here, line straight up from one of the points. Now, I don't know any number that divides equally into 27 and 42. Alright, so I'm going to get you to draw a line at any acute angle here, any acute angle. Mark 4 equal divisions on it. So mark every 10 there. So make the line there 40 long. Join the last point to the corner here. So I'm joining the last point to the corner here. I'm putting a big set square underneath here with my left hand where my finger is clicking. Slide the big set square, the other set square, along each of the points until it hits these lines here. So all the lines have to be parallel. Alright, if you're unsure of that, look up how to do sliding set squares. Right, now we're going to do the same thing again here. We're going to draw a line at any acute angle. Okay, we're going to make it 40 long, or a length that's easily divided by 4. So we're marking every 10 along it. Now, I'm going to join the last point to the corner here. So last point to the corner, sliding set squares. Now, these points along here, the points along the length of the ellipse, have to join to the vertex, and point M is the vertex. Now, the points on the shortest edge of the rectangle go parallel to the axis. So these ones here, where the first hits the first is a point, where the second hits the second is a point, where the third hits the third is a point. And then mirror them across here. Look, line across. Yeah. So put your compass then in the center and swing them around. Okay, and then we're going to sketch those points in. Now, I'm going to pause the video, sketch them in, and then we're going to deal with the tangents to the ellipse. Okay, so we have the parabola drawn in. Now we have to deal with the tangents to the ellipse. Alright, so the tangent line PQ is a tangent to the ellipse from point R. Alright, so let's locate point R. So it's up 20 from the major axis and it's out 110 from the minor axis. So that's point R. Now, to do a tangent from a point outside the curve, you need both of the focal points. Right? When you have the ellipse, okay, the major and minor, take half the major and swing from the top of the minor to get the focal point. Swing from the top of the minor. So half the major swung from the top of the minor, that point there. So that's F1, F2. Join F2 to R. Right, now take your compass, right, put your compass here on R, bring the nib to F2 and swing the circle here. Now set your compass to V1 to V2, so that essentially is the major diameter. Alright, put your compass on F1, so you've set it to the major diameter, and you swing it here. You swing a big arc. Alright, where the arc intersects the circle you just previously drew, you join it to F1. Now, where it pierces the ellipse, that line, that is the point of contact. So that's point Q. And then you can heavy, okay, from R to point Q. Now, and then it's as handy just to join this one to here, because that's point P, sorry. This one here at the bottom is as handy to join to this ellipse. There's your point of, can't do that there, join them there. You have to get R on the other side, so it's down 20, and the best thing to do would just to drop the point of contact right down because they're symmetrical. So there's point S there. If you were to do it again, alright, you'd have to redraw a circle from R to F2 and it'll intersect the same arc. Right, now There's S, so I can join R to S. There we go. Now we've got the parabola. Alright, all we need is the ear and the pigtail. Okay, up 14 from B for the tail. So I'm not going to say much now, I'm just going to do it. For the ear, straight up from the end of the parabola. Okay, radius is 24 and the location is up straight away from here. So analysing carefully your drawing to get, find out the incremental or the angles of lines. So basically the pigtail ear is radius 24. Okay, and if you look carefully, it's this point right across from B and out 27 from the minor axis, joined to the vertex, the minor circle on the major axis, and then it's going right through E, right through that angle there. So you need to be careful with that. That's there. Now T. So just study the diagram carefully to get the angles of lines. Right, so I join this one to there for that ellipse where it intersects the minor circle is what the drawing is showing us. Right, look, those points there, radius 8, you can't see that there. Those points joined where it hits the minor circle, radius 8. Get the curve down here, measure out 55 from the bottom, bottom of the parabola. Right, now I'm going to pause the video heavy in the detail and put it back up. Right, made one small error there. That curve here is meant to be out another 20 from the vertices of the parabola. So I'm just going to have to measure 20. Okay, go over 55 from there. Measure over 20 from the end. So 75, and then measure out 55 there from the end. So I'll do that again. It's there. Okay, same over here now. And then I'll heavy in the, well, I'll heavy most of the detail there. and then just the parabola. Right, and here's what the completed question looks like. So there we go. Oh, one sec there. It's the over 10. Here is a snout. Yeah, you can use that line on a set square. Okay, to line it up. There you go.